Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, for today's lesson, which is 2.18, 2.1.8, I should say, called Solving for X, we are now going to take all of these legal moves that we've been practicing for the past few lessons, and we're going to put them to use when solving equations. Okay, so we'll actually be working with equations and having variables within the equations, and we'll be figuring out what is the value of the variable that makes the equation a true statement. So before we get started with that, we need to make sure we're on the same page with what an equation is in the first place. An equation is a mathematical statement in which two expressions have the same value, which means that they're equal to each other. So if we take a look at an example of an equation, this is an example of an equation. Here's an expression on the left side, here's an expression on the right side. Instead of determining whether or not the left side is less than, equal to, or greater than the right side, we are now saying both are equal to each other. So our task is to now figure out what is the value for x that makes them equal to each other. And you could use the guess and check process if you wanted to, but we're going to use our legal moves. So first thing that we might want to consider here is remember from last year when we talked about getting the x's on one side of the equation, we don't like them being on both sides. The first thing I would do is remove one x from each side. I'll write it nice and small. So if you take away this x, remember we're removing balanced sets. The rule was you had to remove that from each side. And when you do that, you now have a new equation, which is equivalent to the first one. So because we've done the legal moves, we have not changed any values for x. Whatever value for x makes this equation true will also make the original one true because we used that legal move. Whatever we did to the one side of the equation, we do the same thing to the other. We removed balanced sets. Okay. Now, oops, no. Let me change to this. Okay, so now what do we need to do? Now we need to get our x all by itself. So to get it all by itself, we'd want to take away those 3 1s there, right? Take away the 3 from the left side, but you also have to take away 3 from the right side as well. And that's where you get your solution, okay? So the solution is the equation that is as simplified as you can get it. When you finally get your variable all by itself on one side and a number all by itself on the other, this equation, which is equivalent to this one and this one, happens to tell us what the solution is. So if I wanted to prove that 4 is our solution, then I can plug that 4 in here, and I can plug it in here, and then use the order of operations to simplify to prove that each side is the same. And that's what we call the check, where you take 2 times 4 plus 3 is 8 plus 3, that's equal to 11, correct? That should be equal to 4 plus 7, which is 11. So this proves, by doing the check, that when x is equal to 4, this expression is equal to that expression. So that's our goal. That's what we do when we solve equations. Can you always tell whether one algebraic expression is greater than the other? In this section, you will continue to practice the different simplification strategies you have learned so far to compare two expressions and see which one is greater. However, sometimes you do not have enough information about the expressions. When both sides of the equation are equal, you can learn more about x. As you work today, focus on these questions. How can you simplify the expressions within the equation? What will it take to get x all by itself? And is there more than one way that you can do this? And in some situations, is there always going to be a solution? That's kind of an interesting question to ask. All right, so let's begin. Which side is greater? This is the review. This is what we've been working on so far. But I'm going to start having us take kind of get away from using the models and see if we can just solve these symbolically, algebraically. So I would like for you to copy each one of these down, and after you copy down A, I want you to write the expressions that match each one of these tables. For instance, you put your 1 plus your -6, then -1 minus -3. And on the right side, you've got 3 plus 1, -1, 3 plus -1 minus your 2. And so take it from there and simplify using the legal moves until you determine which side is greater. And then this one, they've already given you the original. Oops, I guess I'm giving you a clue that you're going to have to use some distributive property here, correct? So go ahead and work through those, and when you are ready, unpause, and we'll look through my work to see if my work is similar to how you set it up. But ultimately, however you decide, whatever order you choose to simplify, as long as you get the final results that are correct, they're the same as mine, then you've done it correctly. Okay, so go ahead and pause. And when you're ready, unpause, and let's look and see the work to get the answer. All right, so I color coordinated these so it's a little bit easier to tell the two. I didn't want these running together. So the left side here is the blue one, the right side is the green. Here, the first expression is black and the second expression is blue. And remember, we're comparing them, right? So here I would probably start by doing KFC and rewrite this as an entire addition problem. So 1 plus a -6 plus a -1 instead of -1, and plus a +3 instead of minus a -3. Now it's going to be a lot easier to use commutative property and rearrange the order of those numbers to get an answer. Same thing here, instead of 3 plus -1 minus 2 plus a -2. And now combining like terms, it looks like the 1 and the -1 cancel each other out because they make a 0 pair. So you're left with the -6 plus the 3. And on this side, you get your -1 plus your -2 makes -3. And you see what's going to happen there. You're going to eventually have 0 because 3 plus -3 is 0. And here you got more negatives and positives. -6 plus 3 is -3. -3 is less than 0, that means that the right side is the greater side. Okay, so here, using distributive property and KFC, I tend to do those first. And so after rewriting this, I will also make sure that everything is written as an addition. So instead of saying -1 minus a -2x, I just went and said plus a -1 plus a +2x. And then here, send in the dive bombers, you get your 3x. Your positive x, and then instead of -1 plus a -1, or -1 plus a -1, and then instead of minus x and minus a -4, I'm going to say plus a -x and plus a +4, since the negative times the negative makes that a positive. Then we combine like terms. Those are 0 pairs. So you're going to be left with your x plus your 2x. And here, do we have any 0 pairs in here? Yes, the -x and the positive x cancel each other out, leaving you with the 3 plus -1 plus 4. But now you've got this. You got 3x and a 6. So how do you know which side is greater? I mean, you could divide each side by 3 and say x and 2 if you wanted to. But still, if you don't know the value for x, it's impossible to tell which side is greater. Okay? So we're going to start working more with situations like this, where after doing all the simplification, you're left with a variable on one side and a number on the other, but we're going to be dealing with equations instead. So before we get there, let's review this basic idea here. If number 5 is compared to the number 7, it's pretty clear that 7 is the greater one, right? However, if you're going to compare the variable x with 7, how can you tell which one is greater? Because if you don't know the value for x, you don't know if it's smaller, larger, or equal to 7. So consider this as a situation where you got the x all by itself on one side and you got 5 ones over here. If the left expression is smaller, if this is less than this, then what do we know about the values for x? For part B, if this side is greater than this side, then x is greater than 5, right? What do we know about all the possible values for x? And what would we know if these two were equal? What would the value of x have to be? Go ahead and spend a moment writing down the answer to questions A, B, and C. What do you know about the values for x given these circumstances? Well, I feel like this seems pretty logical, where if x has a lower value than 5, then that means that x has to be less than 5, right? So x could be 4, it could be 3, it could be 2, it could be any negative number, as long as it's less than 5. That could be a solution for x. And if you go in the other direction, if this side is greater than this side, then x would have to be a number that's greater than 5, right? So it could be 6, 7, 8, any number all the way up to positive infinity. Now, if we know that these two sides are equal, then what does x have to be equal to? X would have to be equal to 5. So we're going to now switch from having these comparison maps to having what we call an equation map. And the equation map, you can tell it's an equation map because it's got this running down the center of it. It's like an equal sign, right? There's the equal sign, but it's running vertical through the maps. What they're saying is this side is equal to that side. And your task is to simplify both expressions using all the legal moves at your disposal until eventually you find out what the solution is. Okay? So it says obtain the equation map. I'm not sure we're going to obtain the map. I think you could just draw this. Most of the time, when we do this in class, I've stopped printing out these equation maps because it's so easy for students to just draw this in their journal than building things with their algebra tiles. Students stop wanting to use the algebra tiles and just draw the pictures. So just go ahead and draw this in. If you wanted to, you could go to the online book, and there are those student tools that allow you to use those algebra tiles, and you could build this if you wanted to, if you want to continue using these. Otherwise, I'm just going to recommend that we just kind of set up this kind of a format where we're going to write down the entire expression on the left side, the entire expression on the right side, but we're not going to try and determine which side is greater. We know that they're equal, so we're going to determine what value for x makes them equal to each other. Okay, so go ahead and copy this down and set up a table. We are going to continue to justify for the next lesson or so, and then eventually we're going to stop doing the justification. You'll just know in your head that there are those basic standard moves that you can do. So we always start off with the original, right? Here we got 1x plus 1 plus a negative 2 minus a 1 minus the negative 2x's. And on the right-hand side, we've got 5 minus the 1 minus the negative x. So my first strategy has always been to go ahead and do KFC to begin. Don't like dealing with these subtractions of negatives. That makes things a little bit harder. So the x plus the 1 plus the negative 2 can all stay up there, but we'll want to change this to plus a negative 1 when we move this guy across the street. And we'll move these guys across the street, and each one of them will become positive x's. So we now have x plus 1 plus a negative 2 plus a negative 1 plus a positive 2x. And on the right side, we'll move this guy across the street, and it'll become its opposite. And this guy moves across the street, and it's going to become a positive x. So this becomes 5 plus a negative 1 plus a positive x. Now it seems like we should combine like terms and remove any zeros if we're going to combine terms that are different signs. For instance, see these guys here, there's positive, canceling out that negative. Looks like here's a negative canceling out a positive. So what do we end up with here? Looks like right here, that's positive 1 and negative 1 that'll cancel out. And 5 plus a negative 1 gives us 4. So let's see what we eventually get. And I think I might combine the 2x's and the 1x over there. Yes, so we got your x plus 2x is 3x's, and these guys zeroed out, leaving you with just the -2. And on this side, you're going to take 5 plus a -1, which is 4 plus x, or I wrote it as x plus 4. Now we've got x's on both sides. We want to just collect x's on one side. So let's remove balanced sets. And actually, you might even consider, the idea of adding balanced sets as well. Because if I take and subtract away this x from this side, I have to take away an x from this side, correct? But I may also choose to add 2 to this side to make that a 0 pair, which would mean I would have to add 2 to this side as well. So these guys zero out. These guys zero out. 3x minus 1x gives me 2x's. And 4 plus 2 gives me 6. So this is literally saying 2 times something gives me 6 for an answer. Well, what do you multiply times 2 to give you 6? The answer is 3, correct? So that means that x must be equal to 3. And how did we get that? To show our work, we might do something like this, where we divide each side by 2. And that would be your last justification, is dividing at the end. So we could do our standard moves to get our x all by itself, but sometimes there's that one last step of dividing each side of the equation by whatever the coefficient of our x term is. See how we form a giant 1 there? So that becomes 1x, but 6 divided by 2, whatever you do to one side, you've got to do the same thing to the other, becomes 3. So our solution here is x is equal to 3. Okay, now let's take this one. The original equations, or the original expressions, are shown, and it might be good. Maybe we just go ahead and combine like terms right off the bat. So we get 5x plus 1 on the right side by adding the -1 and the 2, that's 1. And here there's nothing to simplify, so we leave that as 2x minus 5. Now we can begin with our adding or removing of balanced sets. And in this case, what would we remove? Probably take away these 2 x's and take away those 2 x's. So you end up with your -5 over here. Oh, I see what I did. I also chose to take away 1, which is the same as adding a -1. So -5 plus a -1 is -6. So yes, I remove balanced sets for both the variables and for the numbers. So we could get these guys canceled out. So you only have numbers, and you'd get those canceled out. So we would only have variables, and that ends up being 3x's. So once again, what do we multiply times 3 to give us -6 for an answer? If I divide both sides by 3, -6 divided by 3 is -2. So that means x is equal to -2. If these two expressions are equal to each other, then x has to be equal to -2. Now there's a way to check that, and we will get into that eventually. But I don't want to pile too much on right now. Let's just go with the processes right now. And then in our next few lessons, most likely we're going to be getting into the importance of checking to make sure that everything was done correctly. All right, so I think this is it. We are going to be done after you do these problems. So copy down each one of these problems. Give yourself room. I would recommend you do each problem one at a time. I can't tell you the number of times I've had students that just write all of these down, but then they don't have any room to show their work, so it becomes a big mess. So write down problem A, then work through the process and declare your answer. Then write down problem B, work through the process, declare your answer, and do each one independently. And when you're ready and you've completed all 6 of them, then unpause, and I will share answers with you. All right, are you ready? Let's start to do the reveal. We start off by copying the problem down. Now, I want to get my x's all by themselves, so I'm going to add 7 to each side, which means this is going to cancel out, but that's going to become a 9. And now 3 times something equals 9. We know what that has to be, right? But when we divide each side by 3, you get our answer, x is equal to 3, so that is the solution. Hey, stop it. Why? No. Yes. That's what I wanted to do. Okay, x is equal to 3. And of course, checking it's not a bad idea. If you could do it mentally, just do it mentally. 3 times 3 is 9, and 9 minus 7 is 2. Which, by the way, a lot of times, that's the way I think of these problems, right? Something. I don't know what x is equal to, so I don't know what 3x's is equal to. But I do know that when you take 9 minus 7, you get 2. So that's how I know that 3x has to be equal to 9. And if I know that 3 times something equals 9, I know it's 3 times 3, then that's how I know that x has to be equal to 3. So a lot of these problems, you can actually figure them out just using a little bit of mental math. But you can imagine how tough that gets here. If you try and do these problems using mental math, it's going to take you longer than it would just take to copy the problem down and work through the steps. So show your work. Copy the problems down, work through your steps. It's going to benefit you in the long run. All right, so we start off by copying down the problem. Then we combine like terms. 2x minus x is 1x. X and x makes 2x's. That minus sign is only attached to the 5, not to anything else. So that's why that's a positive x, and a positive x makes 2x's. Now begin by taking away, and since I've got more x's on the right, I'm going to collect them on the right-hand side. So I'm going to take away an x from each side, and if the x's are going to be on this side, then I have to zero this out by adding 5 to it. So here is an example where we're both removing and adding balanced sets to achieve our goal. So this ends up being equal to 0. This ends up being equal to 0. We end up with x is equal to 6, which is our solution. Okay, and if you're not trusting that, go ahead and plug those numbers in. 6 minus 5 is 1, plus 6 is 7. Here you got 12 minus 6 is 6, plus 1 is 7. So yes, it works. For C, start by copying the problem down. It doesn't look like we need to combine any like terms or do any KFC really here. I would just recommend collecting our x's on the right side because 2 is greater than negative 2. So remember, that's a negative 2x's, that's a positive 2x's. I recommend you always collect them on the side where you'll have a positive number of x's. So if we add 2x's to each side, these cancel out, and you're left with 4x's minus 5 on the right side, and then no x's plus 3 on this side. Now let's go ahead and add 5 to each side. So this becomes 4x is equal to 8. And what number do you multiply times 4 to give you 8 for an answer? It's 2. So our answer for C, x is equal to 2. Is 4 minus 5 negative 1 and 3 minus 4 equal to negative 1? Yes. That balances out when x is equal to 2, so that proves it. All right, let's scroll down. Take a look at D. Here we use a little distributive property to rewrite. I could have said that was plus a negative x, but I figured 2x minus x should be equal, easy to simplify. So 3 and negative 1 make 2, and 2x minus 1x is x. Now we're ready to start subtracting or removing balanced sets. So I take away an x from each side, so I end up with 2 over here because that's zeroed out, and 3x minus 1x is 2x's, minus 6. Now I'll add 6 to each side because I want to get those 2x's by themselves. So it gives me 2x's is equal to 8. And 2 times what number equals 8? It must be 4. So x is equal to 4 is the solution for D. For E, looks like we've got another distributive property problem, but this time we're going to send it into 3 different terms. So send in the dive bombers, that becomes negative x plus a negative 3 plus a positive x, right? Because that's a negative times a negative. And this side is already simplified. So it looks like the negative x and the positive x cancel each other out, leaving you with the negative 3. So now I will add 7 to each side because I want to get my 2x's alone. And that becomes 2x's is equal to 4. So what do you multiply times 2 to give you 4 for an answer? X must be equal to 2. And for the last problem, let's start by combining like terms. 2x's don't have anyone else to combine with, but the negative 4 and the 2 make negative 2. So I can write that as 2x plus a negative 2 or 2x minus 2. And here, combine like terms, you get your 2x's plus your 1. So now, generally what I like to do is collect my x's on one side. But what happens here is if I take away 2x's from each side, because I have to remove balanced sets, then that leaves me with no more x's. And I'm left with a statement that is absolutely not correct at all. -2 is not equal to 1. So in a situation like this, where there is no way that those are equal to each other, then that is a situation where there is no solution. So this will happen sometimes. You might have two expressions, and there is absolutely no way that you could ever come up with any value for x that would make both of those those expressions equal to each other. It just can't happen. Now let's come back up to here for a second. 2x minus 2 is equal to 2x plus 1. If we all agree that the two x's have the same value, both here, come on, and here, then when you take away 2 from something, it can't be equal to if you add 1 to that same thing, right? This has to be less than what you started with, and this has to be 1 more than what you started with. There's no way they're ever going to be equal to each other. So that's a situation where we declare the answer as no solution. And there's no way, you can't plug any number in there that would ever work. It would be impossible. So if you had been doing the guess and check process to try and figure out the value for x to be the solution of this equation, you'd be going forever. You would never find the solution. And that's why guess and check is not an ideal strategy for solving these types of equations. Use the legal moves that we've been working on this chapter, become experts at going through this process and showing your work, and I guarantee you, you are going to have tremendous success with this basic algebra. If you choose not to copy problems and show your work, and you just try and solve things mentally, you're going to have a very difficult time. So please don't try and prove that you're the one student in the history of math that can do all of this without ever showing any work. It's going to be impossible, okay? So take the time to show your work. You'll have more success. You'll get higher grades. You'll learn more, and you'll be better prepared once you make it to high school. All right, it's less than 30 minutes. That was good. All right, go ahead and get headed over to your homework and make sure you copy those problems down and you show your work whenever you can. Take care. Bye. Bye.
Hey, feeling good, like I should.